from data stream given a stream of integers and a window size. Calculate the moving average of all integers in the sliding window. Implement the moving average class. So this is the moving average class. We have our size variable, which is an integer, initializes the object with the size of the window size, and we have our next val integer inside, which is an integer, returns the moving average of the last size value of the stream. So example one, we have our input, our moving average. We see corresponds to 3. That means the size. So we need 3. We're going to go 2 and do 3. So we can see next one, as it shows here, it's 1. So the average of that is 1 divided by 1 is 1. And then we go on to the next value, which is a 10. 1 plus 10 divided by 2, since we have 2 values inside, is 5.5. And we now go to the size. So now we're going to have 3. So 3. So we're going to add all of these, divide by 3, since that's the window size, and get this value 4.667. And now here's what changes. The change happens. So since we have a next now that's more than the size, we're going to take out this one out. And now this one out, and the out is going to be only of these. So these are added, divided by 3, and boom, this we get 6.0. So this can be solved with so we can let's initialize this the size. So the size or size. So then let's call it window size, and make it a queue, because we're going to eventually take out the queue. Set up the window sum, which is equals to 0. So now we're going to check. So now this is basically our setup. Queue data, structure. So once we get to this point, let's check that. So this point over here, once the window size is, if window size is equals to size. So when we do next, and this is already the case, so the size, let's pop out from this. So the oldest one, oldest value will be equals to window this should just be called window. This is where the mix-up happened. The line of window. Window self dot window dot pop left. And now we'll take the window sum, this one, and so self dot window sum and subtract all this var from it. So now we'll move out of this, and the goal is to now append the value into our window. Self dot window the append this val. Now we're going to add that val into window sum. So the window sum equals to val. Now let's return. So how do we calculate the average? So we will do window sum self dot window sum divided by the length of the window. So that's the size of it. So length of window self dot window yes, length of window, because if we do size and we only have this, that will not be appropriate. So this is the best way to do it. So let's save this in the syntax errors. Oops, I found one. Window. Let's see if it runs. Maybe there's no. Alright, and it's been accepted. So the time complexity and space complexity. Time complexity of all of 1 space complexity is O of n, and we can see the space being used depending on the now let's submit to see if it's going to pass all cases, and it's been able to pass all cases. It says 100%, but it's been saying this the whole day, so it's most likely a bug. Or 1 and over n. And that's it for this problem. It's we use a queue for this problem.